In this video I will explain about the altitude of section 10.2. Now, the altitude can only be drawn inside of a triangle. The altitude is a line from a vertex perpendicular to the opposite side. So if I want to draw the altitude starting from a vertex C in triangle ABC, I place the built-in perpendicular line on AB, move it so that I meet angle C, and I draw my line. The symbol that I need is the right angle symbol. Now, in any triangle you can draw three altitudes. This is the one from C. The one from B ends up at AC. So if I want to draw that one, I place my built-in perpendicular line on AC like this, move it up until I meet point B right here, and I draw the line. Don't forget the symbol. The only one that's missing is the altitude from A to BC. So place the built-in perpendicular line on BC like this, go down until I arrive at A like this, and draw the altitude. Now, as you can see, it looks like the three altitudes all pass through the same point. You're going to prove in exercise 11 that is in fact the case. This point is called the orthocenter. Now, there's one important case for the altitudes in a triangle with an obtuse angle, such as this one. This is a triangle in which angle Q is larger than 90 degrees, so this is an obtuse angle triangle. If I want to draw the altitudes here, the easy one is the one from Q to PR. It works the exact same way as the ones before. So I start at Q and I draw a perpendicular line to side PR, like this. Now, if I want to draw the altitude from R, it needs to go perpendicularly to the opposite side, so perpendicular to side PQ. But that cannot really be done inside this triangle. There's no way for me to draw a line inside the triangle that ends up perpendicularly at PQ. So the altitude from R will lie outside of my triangle. What I do is I extend side PQ. I use a dotted line just a few centimeters to the right. And now it works the exact same way. I place my perpendicular line of the geotriangle on PQ, move it up until I find vertex R. And this line right here is the altitude from vertex R. Now, there's one more altitude to draw, the one from P, and again, there's no way to draw the altitude from P perpendicularly to the opposite side of RQ. So again, I'm going to extend RQ. In this case, I have to extend it this direction because that's the only way I can draw the line perpendicular. So use dotted lines to extend. And again, put your built-in perpendicular line on side RQ, move it up in this case until I can draw my altitude right here. Now, we've seen in the one above that the three altitudes all pass through the same point, the orthocenter, and that's the case here as well. We just can't see the orthocenter yet because the orthocenter, again, lies outside of my triangle. All I have to do is extend the three altitudes that I already drew to find where the orthocenter is. And you'll see, again, with a little bit of smuggling, they all pass through the same point again.